In this video, we are going to present the work entitled Simple Database Architecture for Real-Time High-Reliability Distributed Embedded Systems. In this work, we propose a simple and practical yet cost-effective architecture for the database of a distributed embedded systems that provide a high reliable data link between nodes along with a secondary path for all data. It takes advantage of the protocol-agnostic nature of CAN transceivers, affording other protocols the additional reliability required for this type of applications. A challenge: communication between elements of high reliability embedded system often presents a challenge due to their intrinsically low tolerance to data loss and corruption, the unpredictability of environmental conditions that may result in data loss, the problems induced by the transmission line's characteristics, and even noisy transmission media. In many occasions, solutions are required to run on a battery, so the energy consumption of the system must be kept to a minimum. In such a scenario, it's also important to reduce the consumption of the transmission media. These systems often also present the need to sporadically transmit large amounts of low-priority non-time critical data without saturating the main and only data line used. The physical layer of the proposed architecture is based on the use of CAN transceivers due to these advantages: low cost, can transfer up to 40 meters, speed can reach more than 1 Mbps, it has an excellent common mode rejection over twisted pair, low power consumption, compatibility with ISD protection circuit, and compatibility with hot plugging. Regarding the communication protocols, these transceivers don't require CAN-specific signaling. This allows the transceiver to provide the physical layer for a variety of other protocols that encode data and clock in the same signal or that transmit and receive at a fixed rate. The proposed system establishes a two-lane bus, a main lane as principal method for communication that uses a CAN stack, and a secondary lane for bulk data transfer using UART over CAN. CAN provides a very high reliability mode of information exchange, with message quality detection, automatic retransmission of error messages, sender prioritization, and widely supported at hardware level by a large number of microcontrollers. UART for bulk data transfers offers many advantages of its own, as simplicity and ubiquity support. Both are used because the physical CAN layer allows many devices to listen to the transmitted data, which normally would not be possible over a standard UART interface. Error checking that correction must be implemented by the user as they are not native to the UART protocol. For the proposed bus integration, devices on the bus employ the main lane to negotiate the usage of the secondary lane, which may remain in a low power sleep mode while not in use if available on the selected transceiver, drastically reducing the overall energy consumption of the system. Devices that do not need information in the secondary lane may remain in low power mode and safely ignore the messages without disrupting the transmission. The message structure used on the secondary bus may vary depending on the application and its reliability requirements, but it will generally be composed of a header and a payload, followed by a CRC which may be used to verify the correctness of the data. For the experimental setup, 4 devices have been configured as seen on the screen. An experimental rig was built to verify the functionality of the proposed architecture, employing the 4 nodes, as you can see in the screen. This setup was put through a number of tests with varying conditions to verify the correct functioning of each of the parts individually as well as the system as a whole. This test exposed the components and transmission line to increasingly harsher conditions, and unless otherwise specified, testing conditions were carried from one test to the next. As the results for the first experiment of clean environmental, as expected, these tests showed no abnormalities and all the data was transmitted and received successfully without requiring any retransmission. The results for the second experiment, exposure to noise household appliance, results shows that while this appliance introduced noise into the bus signals, it was not significant enough to cause the transmission issues under our controlled test conditions. For the noisy power supply results, initial tests performed without any additional noise-inducing devices were successful. Tests were switched in the same way as in the previous test case and were shown to cause larger spike in the database length. Regarding the manual electromagnetic induction tests, the effects of the zero-crossing switching test were minimal on the power supply outputs. Increasing the phase offset resulted in very noticeable spikes in the power supplies and even larger spike in the bus signal. Now on the screen are shown different results for the different experiments. In this work, we wanted to propose the usage of CAN transceivers as a physical layer for the other protocols and their use in architecting a multi-lane data bus that is both flexible and powerful, while at the same time presenting high reliability and minimal integration costs. The proposed approach opens up the possibility of applying several of the benefits of a CAN boost, like its high reliability and many-to-many communication, to alternative protocols that encode the data and clock in the same signal, such as UART. This architecture limits the protocol to half duplex speed, but this is an acceptable sacrifice in most of many-to-many communication scenarios. Our testing shows that this type of configuration is not only possible but also functional, and demonstrates the capabilities of one such implementation while exposed to increasingly harsher environments. Its reliability might be increased by introducing shielding and foiling around the twisted pair, ensuring that the clean and well-regulated power supplies are used on the bus devices, and keeping the bus wires away from the switching mains power. Finally, references used in this work can be seen on the screen. Thank you.